Hi, myself Ganesh Miriyala from the Department of Electronics and Communication Engineering, MLR Institute of Technology. So in last class we have studied the linear time invariant system for the continuous signal, and this class we are going to be study the linear time invariant system for the discrete time signals. Okay, now see, there is a system and that is discrete. That means you will have the h of n is a system function and y of n is a output, and similarly x of n is a input for this one. So what is the response of the system means, if I say, then x of n convolution with h of n. If you convolve h of n with x of n, then you will get the signal, it is a y of n. So if my signal, if input x of n is equals to del of n, then we are calling it as a impulse response. Impulse response means y of n is equals to x of n means del of n convolution with h of n, which is nothing but h of n, because we are del of n we are considering it for 1 for in convolution process. So then y of n is equals to h of n. So this is impulse response of the system. If we change the input, how we are going to be evaluated? So what is the definition of this impulse response? Summation k equals to minus infinity to infinity x of k h of n minus k, where k rises from the minus infinity to infinity. Is it clear? Next, how we are going to be evaluate the same kind of convolution process by using the graphical method. Okay, now for this one I'll take the same x of n signal, which is given by, in a graphical method we supposed to use the graphical method. So let us take, this is the h of n. Like I am taking it, h of n is equals to, x of n is equals to u of n itself. Next one, same signal I am taking. To make you understand clearly, I'll take 0, 1, 2, 3, 0, 1, 2, 3, and the signal is amplitude, and now we are taking it as a u of n and x of n. This time I'm calling it as a h of n. So these are the two signals. One is x of n and second one is a h of n. But in these two cases I am considering the same signal, it is u of n. Now my y of n must be x of n convolution with h of n, which is nothing but u of n convolution with u of n you supposed to do. The process is very clear, same whatever we have studied in the discrete continuous time signal, the same process, same step, convolution step is same. We are going to be do it now. The first one, where the signal starts from here. First of all, the limits for this one is 0 and 0. That means the sum of these two, you will get the y of n limits are 0, comma, and whatever the last value, you will get the infinity. That means 0 to infinity bit. The same signal you are going to be get it, right? I mean the limits. So now corresponding signal, how you are going to be evaluated? First of all, I am writing the definition. Y of n is nothing but summation n equals to minus infinity to infinity, minus infinity to infinity, x of k into h of n minus k. So this is the thing we need to do it. So the step 1, we calculated the we calculated this one. Now convert changes of axis. Change of axis is nothing but simply I am directly here, I am itself changing these values. Instead of taking x n, I am taking now it is a k. So this is a change of k values. This is h of k and this is x of k, h of k and x of k. Now this step 1 is completed. Now step 1 is completed and step 2 is also completed. This is changing of axis is done. Next one, flipping. I always used to prefer the flipping of h of k. Now I am flipping the signal. So this is as it is I am writing. So there is no change, 0, 1, 2, 3 in x of k. But this time I am trying to flip the signal, that is h of minus k. H of minus k means same, but amplitude is going to be changed, and 0, 1, 2, 3, 4, minus, 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 minus. The amplitude is same, 1 only. Here it is also 1. Now this is the signal which we have. Next one I'm going to be take the, after folding, this is a folding version is completed. Now I'm trying to give the shift. How much shift I'm doing? N units. So I'm taking x over here. X value is here. Sorry, h function is here. So that I am taking k. Now this is a axis h of n minus k. So that I'll take the units from this one. 0, 1, minus 1, minus 2, 2. Now I take k, right? So sorry, n units means n minus 1. This one is a, sorry, this is n plus 1. This is minus 3, right? N minus 3. N plus 1 and n minus 3. This is a my original signal. Now it is a folded and shifted. Now this is a x of k. So if you go into x of k, so this value is 0, 1, 2, 3, so and so, amplitude is 1. Now this is a case. Now we are just simply we are just moving this signal onto the x of k. We are moving and shifting one by one, scrolling the signal onto the one by one. So if you look at here, if this signal is multiplied by, so I am taking the first location. If this k value, if I take n value, this is n is less than 0. That means if n is less than 0, that means this signal we are placing over here, because there is no collapse. That means there is no overlapping of the signal, because less than 0 means this signal, if n plus 1 is nearby here only, then we won't get the any overlapped signal. So once if I take n greater than 0, that means for n is equals to 1, for n is equals to 1 incident, then I'll get the signal over here like this. That means there is a overlapping between these two signals. For n equals to 1, then the overall signal value is 1 plus 1, which is equals to 2 you will get. Okay, so 1 plus 1 you will get the 2 you will get. The next one, if I shift to second case, that means I'll get the second case like this. One more I'll add it over here. So one more and one more, one more. But only you will get the two signals over there. Two of the signals, you are multiplying these two signals and adding those two signals. So like this. Where is the function? Now summation k equals to 1 to, first one it is, if I take 1 to 2, then x of k, h of n minus k. Let us take from 0. K equals to 0 to 1. Then let's look at here, x of 0 into h of minus, if n equals to, sorry, k we are putting, right? H of x of 0 and n minus 0. So like this you are going to be evaluated. For the next one, 1 plus 1 plus 1, you will get the 3 value. 1 plus 1 plus 1 plus 1, you will get the 4 value. That means for n is less than 0, you will get 0. For n greater than 0, then you will get the answer is, for any k equals to 1, you are getting 2. K equals to 2, you are getting 3. For k equals to 3, you are getting 4. That means this n value for you are getting k plus, for k equals to 0 to n minus 1 value, then you are getting the value, it is like n plus 1. Plus 1 we are adding. For k equals to 2, you are getting 2. So k equals to 3, you are getting 3. That means n plus 1 you are getting the signal. Right? So I can write y of n is equals to simply I can put 0 for n less than 0 and n plus 1 for n greater than 0. N plus 1 for n greater than 0, which implies I can write what is n greater than 0. If I write the u of n function, if I write u of n function, that is 1 for n greater than or equals to 0, 0 for n less than 0. Similarly, what I written, y of n is equals to 0 for n less than 0 and n plus 1 for n greater than or equals to 0. So if you see the same signal, I can represent y of n is equals to 0 is as it is same, n less than 0. Instead of n plus 1, I am writing it is a n plus 1 into u of n greater than or equals to 0. So in this way we are going to be evaluate the in graphical convolution for discrete systems. Next time, so is there any other methods to evaluate the discrete time signal convolution? Of course, we will have the discrete time convolution for different methods. One is I am taking it as a tabular methods. It is a tabular method. First one, let us take x1 of let us take x of n and 1, 3, 4, 5. This is a one signal, and second one h of n is 1, 2, 1, 2. This is a another signal. So how to evaluate the convolution in between those two signal means there is a table form, write in column format and rows format. First one I am writing it as an x of n 1, 3, 4, 5. This line. Similarly, in this line I am writing it as a h of n. H of n is 1, 2, 1, 2. Okay. So because we are putting in a table format, multiply this one with this entire row. 1 multiplied by 1, 1. 1 multiplied by 3, 3, 4, 5. Next to 2, 2 3s are 6. 2 into 2 multiplied by 4 it is 8. 2 multiplied by 5 it is 10. 1 multiplied by this one it is 1, 3, 4, 5. Similarly 2 is there. 2 multiplied by 1 2. 2 multiplied by 3 it is 6, 8, 10. So this is a table, you got it. To get this y of n value, take the diagonal elements, first one. So how many values are there? This is the first, only one is there. Take it as 1. Next, for the second diagonal, you will have the two values. 2 plus 3, it is a 5. Next diagonal value, you will have the 164. 164 means it is a 11. Next, highest diagonal value, it is this one. 2, 3, 8, 5. Then 2 plus 3 plus 5. If you do it so, then you will get the 18. Next one, this diagonal value, 6 plus 4, 10 plus 10, it is 20. Next one, you will have the 8 plus 5, it is 8 plus 5 will it as a 13. Next one, finally it is 10. So in this process, we are going to be do the tabular method convolution if for the discrete time signals. Okay. So for suppose there is a 0 location of this signal. There is a 0 location for this signal and 0 location for this signal. Okay. At 2 you will have the 0 location, and this one at 2 will have the 4, at 4 will have the 0 location. Now where we will get the 0 location in the resultant signal? Just simply see where the 4 is there. So this one is a 4 line. This is a 4 line. Next one, where the 2 is there, first 2. So this is a first 2. Write the straight line over from here to here. Write the straight line over from here to here. Intersect this one. The intersect element is 8 actually. So where this 8 included, that means the highest diagonal value. Highest diagonal value is this one. So 18. That means you are putting like this. Is it clear? So to better understand, I will do the one more thing. Right? So I will take the one more example. For suppose x of n is equals to 1, 2, 2, 1, 2, and next one h of n is equals to 1, 3, 3, 1. So this is my signal, and its 0th location is here, it is 2, and its 0th location is this one. So what is the resultant signal and the convolution of x of n and h of n? Now I will take the by using the tabular method. So by using tabular method, now I can write first of all I am writing x of n. X of n is 1, 2, 2, 1, 2. Next one, this is h of n. H of n is equals to 1 3 3 1. Okay, now multiply these two signals, this one with the all rows. So first row, that is 1 multiplied by 1 1 2 2 1 2. Next multiplied by 3 3 multiplied by this row, entire row. So 3 1 3 6 6 3 6. Next 3 multiplied by same row, that means you will get the same values. 1 multiplied by the same row, that means 1 2 2 1 2. So this is the signal you have. Now my y of n, I can write the first diagonal element is, will have only 1, so that the value is 1. Second diagonal element 3 plus 2, that means value is 5. Third diagonal is 2 plus 6 8 plus 3 11. Next one, this is a value 166, that means 12 plus 14. Next, this is another diagonal 2 6 3 5, that means 5 11 13. And this one is the next one 6 3 9 plus 2 11. This one is 1 plus 6, it is 7, value is 2. So this is the signal. But where is the zeroth location for this one? So take the third 2, that means this one, third 2, and next one 1. So this is a 1 value. So we are including in this case. So which diagonal? 1 2 3, third diagonal. 1 2 3, third diagonal result is this one, that means this is a 0 location. Okay, so next one, matrix method. So next one, it is a matrix method. So for same, I take same example 1 2 1 2. Next one, it is h of n is equals to 1 3 4 5. This is a signal, right? How the matrix method we are going to be do? So matrix method, you write in the column wise for each and every one until the number of rows will completed. That means I am writing 1 2 1 2. So this 2 is ended, right? Now again start with the 2 only. 2 completed, again start with 1 2 1. 1 is completed, again it is 1. After 1, which we are getting, after 1 it is, you are taking from here itself 2 1 2. Next 2 1 2 1. So this is the matrix, and which you need to multiply with the vector 1 3 4 5. So by multiplying this, you will get the value 1 this row multiplied by this column, like 1 1 plus 6 plus 4 plus 10. This is the first one. 2 plus 3 plus 8 plus 5. Next, so these two are same, right? Means we will get the 1 plus 6 plus 4 plus 10. So these two are same, means we will get the 2 plus 3 plus 8 plus 5. That means we will get the 10 21. Next 2 3 8 5 15. Next to 21. So we will get the 50, like this. So this is the way to evaluate the matrix method. So what we studied in this one, finally we studied about the convolution for discrete time signals. First method, graphical, we covered. Second one, tabular method. Third one, which we discussed about the matrix method. In next class, we will see the Fourier transform. Thank you.